Hi, my name is Karan Agarwal and I am giving the presentation on the topic operational amplifiers, also known as OPMs. So, the points which we will be covering in today's topic will be what is an operational amplifier circuit diagram, operational amplifier pin diagram, how it looks in real life, operational amplifier classifications and its applications, and a brief about inverting OPM, non-inverting OPM, OPM integrator, and at last OPM differentiator. So the first question arises in our mind is what is an amplifier? So an amplifier is nothing but an electronic device that can increase or amplify the voltage, current or power of an electronic signal. So back to our main question, what is an operational amplifier? An operational amplifier is an integrated circuit or an electronic device that can amplify weak signals as well as perform multiple mathematical operations such as addition, subtraction, differentiation, integration, etc. As a matter of fact, the name operational amplifier itself is derived from the fact that it can perform various multiple mathematical calculations. So, to understand more about operational amplifiers, let's have a look at its circuit diagram. It is an three terminal device out of which two input terminals and one is the output terminal. So the terminal that is connected to the positive end is known as non-inverting terminal and the other one that is connected to the negative end is known as inverting terminal. Here V positive is the positive voltage supply and V negative is the negative voltage supply, and the last one is the output terminal from where we will get our output. So moving on to its pin diagram, it is the pin diagram of the most common OP-amp, that is 741, and it is also used in various integrated circuits as well as components electronics components, sorry. So the first one pin is offset null, second one is the inverting input terminal, third one is the non-inverting input terminal, fourth one is the negative voltage supply, fifth one is the offset null, sixth one is the output terminal, seventh one is the positive voltage supply, and eighth one is the no connection. So now we have understood the pin diagram and the circuit diagram of the operational amplifier. So it is also important to have a look at its real life diagram. So here it is how it looks in the real life. It is basically more like a pin diagram, but still it's important to have a look at its real life diagram. So moving on to operational amplifier classifications. Operational amplifiers can be classified into four ways. First of all, voltage amplifiers that takes voltage as an input and produces voltage at the output. Second is current amplifiers that receives current as an input and produces current as output. Then comes transconductance amplifiers that takes voltage as an input but produces current as an output. Last one is the transresistance amplifiers that takes current as an input and produces voltage as an output. Out of all these operational amplifiers, the most commonly used op-amp is the voltage amplifier. So next is the op-amp applications. So first of all, op-amp is what forms the basic building block of linear and non-linear analog systems, and it has countless applications, yet we will try to cover some in this topic. So these are as follows: inverting op-amp, non-inverting op-amp, op-amp integrator, op-amp differentiator, summer, subtractor, instrumentation amplifiers, voltage followers, and so on. So let's have a brief chat about this. Inverting op-amp. So in this configuration, the output is fed back to the negative input through the resistor R2, and the input signal is applied to this inverting pin, that is negative terminal, via resistor R1, while the positive connection is grounded. So this configuration produces a signal that is complementary to the input, as the output is exactly opposite of the input signal, as there is the name inverting. So now non-inverting op-amp. In case of non-inverting one, the input voltage is applied directly to the non-inverting pin, that is the positive terminal, and at the end of feedback loop is connected to the ground. So it allows amplification of one signal. So second last is the op-amp integrator. So the op-amp integrated circuit is normally a circuit that has an op-amp with a capacitor replacing the feedback resistance. The capacitor is placed between the inverting input and the output. So it performs the mathematical operations of the integration. Suppose we want the triangular wave, so we will just simply integrate the square wave to get the triangular wave, as we can also see it in the figure. Similarly, the op-amp differentiator. Op-amp differentiator configuration is also similar to integrator, just by reversing the positions of capacitor and resistor, as we can see in the figure. So the basic operational amplifier differentiator circuit produces an output signal which is the derivative of its first input signal. So suppose we want a rectangular wave, so we will simply differentiate the triangular wave to get the rectangular wave. So that was all for today. I hope you listened it to carefully, and thank you and have a nice day.